Today we are going to talk about parallelograms and their properties. I want to emphasize that the quadrilateral tree is something of very much importance. So you may want to pause at the end or in the middle of the next slide so that you can copy things down. But we are going to talk about parallelograms and their properties. So the first thing and the easiest thing to do is we've got a quadrilateral tree. Okay, in the quadrilateral tree, we have the quadrilaterals. A quadrilateral is a four-sided polygon. So anything that falls under this tree has four sides. Now, as with any tree, we have branches. So off to the left, we have a parallelogram. Then we have a trapezoid on the right. Okay, a trapezoid has one set of parallel sides. A parallelogram has two sets of parallel sides. Opposite sides are congruent. Opposite angles are congruent. So these are the properties of our parallelogram. As with the trapezoid, the property of a trapezoid is one set of parallel sides. Also with the parallelogram, diagonals bisect each other. Bisect means they cut in half. Okay? Under the parallelogram, we have a rectangle. We also have a rhombus. A rectangle has four right angles. Now, please keep in mind, in addition to the four right angles, a rectangle is a parallelogram, meaning it has two sets of parallel sides. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other. Okay, but a rectangle specifically not only has all of those, but specifically has four right angles. The diagonals of a rectangle are congruent. Now, please remember the diagonals aren't necessarily congruent in any parallelogram, but in a rectangle, the diagonals are congruent. A rhombus has four congruent sides. The diagonals are perpendicular. The diagonals bisect the angles. Under the rectangle and rhombus, we have a square. A square meets all of the qualifications above. A square has two sets of parallel sides. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other, okay, because a square is a parallelogram. But a square is also a rectangle, meaning it still has four right angles, that the diagonals are congruent. But a square is also a rhombus, having four congruent sides, the diagonals being perpendicular, and the diagonals bisecting each of the angles. So all of these properties are of the utmost importance. Now, we have another branch, which is a kite. A kite is a quadrilateral, just like a trapezoid. All of these have four sides, but a kite specifically has two pair of consecutive congruent sides. The diagonals are perpendicular. And you have exactly one pair of opposite angles being congruent. Now again, this quadrilateral tree, you need to be able to create it. You need to be able to write down all the properties specifically applying to each one. So you might want to pause it and continue. Okay, we've got some practice problems. You want to pause this. Write down each problem in your math journal and work it. Once you have finished all 5 problems, unpause your video and continue. A quadrilateral is a polygon with 4 sides. Now, when you have 4, please write, instead of using the number 4, if you are filling in the blank or something like that, write out 4 as a word, F-O-U-R. So a quadrilateral is a polygon with 4 F-O-U-R sides. The blank of a parallelogram bisect each other. Okay, well, of a parallelogram, if we're just talking about a parallelogram, we're talking about the diagonals. The diagonals of a parallelogram bisect each other. If a quadrilateral is a parallelogram, then it has two sets of, if it's a parallelogram, we have two sets of parallel sides. If a quadrilateral is a parallelogram, then the opposite sides are congruent. Now, in this figure here, it says find the distance from T to R. So we are looking at just a parallelogram. See where we have two sets of parallel sides that are marked. Well, a parallelogram has diagonals that bisect each other. So TR has been bisected by QS. So we set the two parts, 2x minus 5 and x plus 4, equal to each other, okay? Because the diagonals bisect each other. So 2x minus 5 equals x plus 4. I'm going to add 5 to both sides. I'm going to subtract x from both sides. I get x equal to 9, but they didn't ask me what x equals. They want the entire distance from T to R. So 9 plus 4 is 13. Okay, I can either take that and just double it, or I can take 2 times 9 minus 5, whatever. Regardless, I'm going to get 26, and it is 26 units. Okay, this is our practice problem set 2, so you may want, once we get to the next slide, you want to pause the video. You want to write all of your questions in your journal. Once you have written them in your journal, you may continue. So again, you want to write these in your journal. Be sure you write them out because you're going to need to take a picture of them when this is all said and done. So pause the video and then you may continue. A trapezoid. A trapezoid is well, if we stop and think about it, think about your quadrilateral tree. Your trapezoid fell under your quadrilateral. So a trapezoid is a quadrilateral because it is a four-sided polygon. So it is a quadrilateral. The diagonals of a rectangle. Okay, if we're specifically talking about a rectangle, the diagonals of a rectangle bisect each other, or are congruent. The diagonals of a parallelogram bisect each other. The diagonals of a rectangle are congruent. Number 3, the sum of the interior angles of a pentagon. Well, remember a pentagon has 5 sides. Okay, so it'd be 540 because we take our sum, equals our number of sides, 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is 540. Now, if we look at number 4, we have another parallelogram. We don't know that this is a rectangle or anything else. We just know we have 2 sets of parallel sides. If we have 2 sets of parallel sides, we have a parallelogram. Parallelogram diagonals bisect each other. So D to E is equal to E to B. So I can set negative 2x plus 6 equal to x plus 12, and I'm going to solve. I'm going to subtract 6 from both sides, subtract x from both sides. So negative 3x should equal a positive 6. Divide both sides by a negative 3. So x should equal a negative 2. Okay, well, you think, we can't have a negative length. Well, plug it back in and let's see what we get. As long as our length isn't negative, we're probably okay. So negative 2 plus 12 is 10. And a negative 2 times a negative 2 is a positive 4. Positive 4 plus 6 is also 10. So we are right. But we want the distance from D to B, so we have to double that. So we should have 20 units. Moving on to number 5, the measure of an interior angle of a dodecagon. There's several ways that we can do it. The sum, again, equals n minus 2 times 180. A dodecagon is 12 sides. So we have 12 minus 2 times 180. 10 times 180 is 1800. So we just want at one angle, so we have to divide by the number of sides. 1800 divided by 12 is 150 degrees. Number 6, what is the sum of a measure of the interior angles of a hendecagon? Well, a hendecagon is 11 sides. Okay. Oh, I'm sorry. Let's talk about the sum of the interior angles of a polygon, another way to do it. Any polygon, the exterior angles equal 360. So I can take 360 divide by 12. That gives me an exterior angle. Okay. So one angle is 360 divided by 12, which is 30. But that's going to be supplementary. That's an exterior angle. That's going to be supplementary to the interior angle. So I can take 180 minus 30, and I get 150. So either way you do it is acceptable as long as I'm able to see your work. You have to show which way you did it. So now we'll continue to number 6. The interior angles of a hendecagon is 11 sides. We have n minus 2 times 180. 11 minus 2 times 180, we get 9 times 180, which is 1620. And that they don't want one measure, they want all the measures. So that is the sum of all the measures of a hendecagon. Number 7, if ABC or ABCD is a rectangle, then AC. Now, if we stop and think about it, and I drew my figure, I drew a rectangle, and I started in the upper left corner, and I went clockwise, A, B, C, D. A to C is a diagonal. Okay, so if A to C is a diagonal, B to D is a diagonal, and in a rectangle, the diagonals are congruent, so A to C equals D to B. Now we're going to talk about kites. Kites have two sets of consecutive congruent sides. So we have two pair of consecutive congruent sides. So right next to each other, consecutive is one right after the other. So A to B is congruent to B to C. A to D is congruent to D to C. Now remember, we don't have parallel sides. This is just a quadrilateral. In a kite, we have two pair of consecutive congruent sides. The diagonals are being perpendicular, so the diagonals would be B to D and A to C. Perpendicular. Perpendicular means we form right angles. Okay, always remember when we're working with right angles and we've formed right triangles right here, the Pythagorean theorem can often be helpful. Exactly one set of congruent opposite angles. So we either have A to C is angle A is congruent to angle C, or we have angle B congruent to angle D, depending on the information that we're given. We don't have all of them congruent, but we do have one set of opposite angles being congruent. Now, a trapezoid. We have two types of trapezoids. We have a regular trapezoid where we have one set of parallel sides, and then we have an isosceles trapezoid where we have a set of parallel sides but our legs being congruent. Any legs of a trapezoid are the sides that are not parallel. So the legs of an isosceles are the sides that are not parallel. So a trapezoid has one set of parallel sides and an isosceles has congruent legs. Okay, so we have our legs here. The parallel sides are the bases of the triangle, or I'm sorry, of the trapezoid, and the other sides are our legs. Okay. Trapezoids. We're going to talk about the median of a trapezoid. Okay, the median or the mid segment of a trapezoid is a segment that connects the midpoint of the legs. So please keep in mind that they're the legs of any trapezoid, not necessarily an isosceles trapezoid. So if the median connects the midpoints, I've now got a bisected, or I've got two bisected legs. Okay, that is my median. Now we're going to continue discussing the median. Now the median or the mid segment of a trapezoid equals half the sum of the bases. So M would equal 1/2 A plus B. Okay, so this segment equals half of A plus B. So if I look at this, if I want to find the distance from F to E, I'm going to add 9.4 and 7 and divide by 2. Okay, so 9.4 plus 7, 16.4, multiplied by a half or divided by 2 is 8.2. So F to E is 8.2 units. I can work another one. I'm going to add 23 and 31 and divide by 2 or multiply by a half. 23 and 31 is 54. Half of 54 is 27. So K to L is 27 units. We are done for the day.